Go ahead.
Hi, I'm Dan, musicyoda.com. That is my website. Also, you can see me anytime you want, and that's DANSING124. That is my YouTube channel name. Now, what I'd like to present today would be for the math group. How about the Beal group? Don't you understand? The Beals love space, outer space. Now, when we look at things come over the sky, they don't last very long. We have light pollution, we have air pollution, we have every kind of pollution that you could think of that will deal with the problem of you viewing an object coming over. So, here's my solution to the problem. I'll explain it a little better later. Observation time where h is height, less than 1 statute mile. Go to Mile High Stadium if you like it better there. That's a good place for an observatory, and you know we have plenty of them. And 7926 miles is the Earth's diameter, average, and mu sub r is Newton's rocket equation, I call it, which simply stands for the velocity is equivalent to the square root of 9.56 times 10 to the 4th power over r plus h sub r, which is your rocket. Okay, and delta is any applicable rate of change, all right? So what we have over here will be this, and I'll read it to you very quickly. Delta t equals the integral from 0 to delta 2h, and the square root of h divided by 5280 multiplied by 7926. Oh, then we have to separate that because now we figured out delta 2h. Delta 2h divided by mu sub r. Therefore, the Earth's rotation, wobble, and spacecraft's direction of travel will have little effect on results, yet correct locality will. What's correct? Are we going to be 10 miles in the air, or are we going to be right on the ground close to, where we can see across, our eyes are, about 5 feet tall or something like that. So, travel will have little effect on results, yet locality will. That's very important to understand. I repeated that very intentionally. Now, higher orbits and any parabolic and hyperbolic ellipses with eccentricities approaching 1, we're leaving Earth orbit. We're not supposed to be able to do that according to hoaxers. Mean longer observations, right, as with Apollo 8, Apollo 10, Apollo 11, Apollo 12, Apollo 14, Apollo 15, Apollo 16, and Apollo 17. Thank you very much for your time, folks, and keep on playing your piano. Make sure it's the Beals. We got Hey Jude. No, I don't think we do. But Beals fans and math fans will appreciate this just alike. It's just my way of saying it. And then, now, let's present the equation to you so that you can see it. Oh my God, it looks backwards.
It's not going to.
Yeah, take a look at that equation. I want you to study it. I want you to use it. It does not work for every single thing possible to mankind. If you look at something in a polar orbit, what you'll understand right away is that this equation will not apply. This applies east to west mostly. West to east mostly. West to east, not east to west. What am I talking about? Well, that goes into the polar aspects of this equation. What you need to use it for its purpose, not out of context. In context means this is your observation time. And I'll tell you, for something 250 miles up in the air, at least on level playing field, you'll get about 1.15 seconds. You got to keep your eyes ready. They tell you you've got 5 minutes. Well, you don't have 5 minutes. Well, I got 5 minutes right now. I gotta get off. Love you guys. Thank you. Thank you, math group.
Peace out.